hello everyone and welcome to the session. So in our today's session, we will learn about indexing and performance optimization. So basically, this is the series for the SQL Basic to Advanced the session with practically session. So basically, in that we will learn the basic. The previous 6 day we will also go through the different SQL concept, and now in the day 7, so we will go by the performance tuning, then how we can optimize the database. So this is a question oftenly asked during the interview, or if you are the working professional, then this is the mind we you are going through this scenario. Okay, so in a day 7 we will go through the different type of indexing, why we will use this index, then what are the different type of performance optimization technique available in a SQL. Okay, also we will go through the practically session as well. So we will also check how we can optimize using the SQL Server Management Studio. Okay, so let's start the session, and end of the session I will open for the question. If you have any question, you can ask that question, so we will take that question. Okay, so now so for the indexing and performance optimization, so basically in a day 7 we will take the theoretical part, like understanding the indexes, like the cluster index, non-cluster index, then optimization query using the index, then analyzing the execution plan. Okay, so how we can analyze the plan, then we will also check the practically the session. So for that we will create a cluster index, non-cluster index, then compare the performance before and after the indexing. Okay, and then the query execution plan, also we can check the analysis for the how we can analyze the query execution plan. So these all the things we will conclude in today's session. So this today's session very interesting session, so you can watch this session till the end of the session. I will also give the some important tips that helpful you for the optimizing the your database. Also I will conduct one real-time scenario that it will be helpful you for the performance optimization within your database. Okay, so first of all, we will go through the theory part. So the theory part basically in this understanding the indexes. So what is the indexes? Okay, so this concept basically we will check the concept for the indexing. So indexes in a SQL Server work as an index in a book. So you are having the notebook. In that notebook, first page is the index. So index indicating the which topic in a which number of page. Okay, so same like that in a SQL Server also. If whenever we store the large amount of data, like 1 billion of data, so that time we will arrange the data in a particular order. So so it's like that ki whenever we retrieve the data from that table, so we will get the data easily in a less time. So the same concept in a indexes will be applied. So whenever we apply the index, so index will be formed like it will be given the particular range for the inserting the data, and it will be helpful for the database engine for the locate the data faster without the scanning the entire table. Okay, so there are two type of the scan: index scan and table scan. So we will check in the next concept. So basically as of now we will focus on the indexes. So there are two type of indexes: cluster index and non-cluster index. Okay, so basically the cluster index sort or store the actual data rows in a order. Okay, the table have the only one cluster index. Okay, whenever we have the create any kind of the table, that time the default the primary key create a cluster index on the primary key column. So that I will show you in the next session for the practically. So the non-cluster index, so basically the contain the pointer to the actual data. You can have the multiple non-cluster index on the one table. Okay, so for the creating the cluster index, non-cluster index, but before that we will check the difference between the cluster index and non-cluster index. Okay, so basically the difference, if you check the definition that I already told you, cluster index determine the physical order in a data in a table. Okay, there are can be only one cluster index per table because of the data row themselves store in a order of the cluster index. Okay, so this is the basic the definition for the cluster index. So think a little bit dictionary arranged in alphabet order. So it is the one kind of the index. Okay, so this is the real time example. So we will check the example as well. So you have the sales table. For example, if you have the sales table, in that sales table million records, okay, and the report often the query data by the sales date, okay. So then in this case we will apply the cluster index on the sales date, because of the data will be retrieved based on the sales data. So for the creating the cluster index, so create, then cluster index, then this is the index name like ix underscore sales underscore sales date on the sales. This is the table name. So when we run the query, like select star from sales where the sales date between the like 2024 first of first, then and 2024 12 31st. So this is the date range that we filter the data. So because of we apply the cluster index, so it will be data will be sorted based on the cell date. So it will be easily data will be retrieved from the table. So you can check SQL Server quickly seek the required the range since the data is physically sorted by the cell date. So this is the benefit for the cluster index. Okay. Then for the non-cluster index, so basically the non-cluster index create a separate structure for the data row. It is the store the indexes column along with the pointer. Okay, so in a non-cluster index, we will point the any particular the column. Okay, so row locator in the actual data. So think that like for example index at the bank of the textbook, like that point you for the extract the page. Okay, so the real-time example, for example, we have the customer table and user frequently search the email ID. Okay. So for that time, how we can apply the non-cluster index. Okay. So for that, creating the non-cluster index, like the SQL syntax create, then non-cluster index. This is the naming. Then the after that we will add the name like ix underscore customer underscore email. This is the name of the non-cluster index. Apply on the customer table, and then we will pass the column name. So email is my column name for the this particular table. So whenever we perform the query like select customer name from the customer name from customer where the email id equal to john at the rate example.com. So whenever we filter the data based on the email id, that time this non-cluster index will be quickly find the record from the billions of the data. Okay, so this is the basic difference between the cluster and non-cluster index. Okay, so we will check the comparison. So the for the data storage, then the cluster index basically physically store the data. So it will be take the physically the data store in a particular database. So it will be required the space for that. And for the non-cluster index, separate data, actual data, separate from the actual data means it will be not the same table. It will be separate from the actual data. Okay, then number of table, so we can apply the cluster index only one time in a one table, but for the non cluster index we apply the multiple the columns. Okay, so speed, so the cluster index is a faster range for the queries, and it is also faster specific lookup. Okay, so it is also non-cluster index also it is the faster, but if we apply the multiple non-cluster index, then it will be get the performance issue, it will be getting the slow. Okay, in that case only include all column. So can we include the all the column in a cluster index? So yes, we can include all the column. If suppose the table having the 10 number of columns, so we can apply the 10 number of column in a cluster index. But for the non-cluster index, it is not possible. We can unless we can include the option. So we can apply the include using the option. Okay, then use case, so basically the cluster index basically useful for the range queries sorting the joins. Okay, whenever if suppose we have the store procedure, and that store procedure the based on the different query like select insert update, and it will be sorting the data based on the joins. Okay, so that time we can apply the cluster index. And whenever the non-cluster index, so basically the searching filtering specific the lookup. So for example just now we check that using the email id, if we filter the data, then we can apply the non-cluster index. Okay, and basically the one thing that you are in mind. So basically the cluster index also perform the same operation, then why the non-cluster index? Okay, So basically the cluster index, if you check, the only one cluster index we can apply in a one table. But if suppose there is a situation that we also require the cluster index for the other column as well, so that time it is not possible because of cluster index. Only one cluster index we can apply in a one table. So that time second option is that we can apply the non cluster, we can create a non cluster index for the other remaining column. Okay, so this is the example. So we will check the real time example, the scenario for the HR system. So in the HR system, so cluster index we can apply on the employee ID because of the employee ID is the primary key. Okay, and for the join with a different the table, so non cluster index, so last name, department ID for the search filter in the report. Okay, so this is the example. And then query performance tips. So for the cluster index, the data is often the query in a range or order. In a non-cluster index, specific in a where condition. Okay, so the might be that column like department ID, last name, search, it will be in a the filter condition. Okay, so this is the example for the cluster and non-cluster index. Now we will go through for the next session. Okay, so we will check that how we can create a cluster index, non-cluster index. Then we will go to the next section. So optimize the query using the indexes. Okay, without index and with index, how we can optimize the query. So for that, we will check the real time scenario. So how we can create the index and then how we can search the index. Okay, so for that, analyzing the basically analyze the execution plan. So for the analyzing the execution plan, so we have the in SQL Server we have the table scan, index scan, then index 6. This is the optional, and this is will be we will check in a practically. Okay, so this way we can find the how we can check the execution plan. Okay, so for the analyzing the table scan or index scan, then it will be we will take the one real time example. Okay, so the now the we will go by the practical session. So basically for that we will create a one table. So this is the first basic example, and then we will go to the for the optimization. Also we will check how we can optimize the query. Okay, so once we completed this one, then we will also go to for the optimization of the SQL Server database. Okay, so first thing, I will directly copy this query and I will come to my SSMS. Okay, so this is my SSMS and I will click on the new query. Okay, so here I will what I will do, I will create a one table like EMP table. Okay, so create table EMP. So EMP ID is a primary key. Okay, so because of it is a unique, then EMP name, department name, salary, and date of joining. So the you can check whenever we create a table with a primary key, so default clustered index will be created. So that I will show you then practically also. So as of now I will directly execute the query. Now the table is created, so we have created a EMP table. Like select start from EMP. Okay, so this is my table. Okay, so I will execute the table. As of now there is no data. So but if suppose we will refresh the data. Okay, now we will refresh the data, and now I will show you how we can check the table. Okay, so this is my database, learn SQL, and this is my table. So just now we have created this EMP table. Okay, so if we click on the plus icon, then you can check the different, the option is columns, whatever the columns in that table. Then second one is the key. So whatever the key we apply, so the first key is the pk underscore emp. So this is the key, so this is the pk means primary key. Okay, then constraint. So if any kind of constraint we apply over the table, then it will be show here. Then trigger, then indexes. So if we click on the indexes, then you can check we have not created index till yet, but the default index will created. So this is the pk underscore emp, this is my default the index. So if we go to the script index as create and with new window, so you can check this is the the default the cluster index will be created by the SQL Server engine. Okay, so basically the thing is that, so whenever we create a table with primary key, so default the the cluster index will be created. Okay, so this is the thing that I explained you. Okay, so this is the index that we have created. So now it will be executing. So once it will be executed, then we will check the detail of this the cluster index. Okay, action and then storage, then fragmentation. So in a fragmentation, you can check. So the index type is a cluster index. Okay, so that means कि whenever we create a table with primary key, that time cluster index will be created automatically by the SQL engine. So now we will create the table. Now what we will do? We will insert the data in this table. Okay. So for the insert, I have all. I will give the all the script in a video description box. You can check the all the script, and you can also prepare for yourself. Okay. Okay. So I will copy this script. So basically this is the script that will be insert the data into the this table, and we will insert the 1000 record for the sample. This is sample script. Okay, so I will copy and I will come here and I will paste the data. Okay, so with number, so this is script that basically it will be inserting the 1000 records. So if you need the 2000 record, then you can change the number. So basically this is a row number. It will be create a 2000 records, and it will be automatically create a system dot object s1 cross join with s2, and basically this is the insert script. So if we execute this script, then 2000 record will be created. Okay, column name requirement. Okay, so employee. Okay, sorry. So emp. Okay, so 2000 record will be affected. Okay, so now we have the created the table, we have the inserted the data, and now time for the check the optimization. Okay, so problem statement is that, so improve the performance for this query, find the employee by the emp id. Okay, so if suppose there is a the as of now there is a 2000 record in my table, and if you fire this query, then it will be might be get the performance issue. Okay, so for that I will what I will do, I will execute the query. Okay, so the as of now the basically there is a two thing whenever we perform the issue. So testing without the indexes. As of now the index will created. So what we'll do? So we will drop the index. Okay. So first of all we will drop the index. So for that I will directly execute this pk underscore. So if it is not access, then we will check what it will be used. So it will be not allowed, but we will try. So it will be not allowed because of it will be being used for the primary key constraint. So we need to remove the primary key constraint. Okay, so if we remove the primary key constraint, so let it be. So we have to disable the index, and now if we check the performance, so for that what we'll do, so we will run this query. Okay, so I will copy this query, and now I will, if I execute this query, so it will be take the some seconds. Okay, so how we can check the query will be taking the time or not. Okay, so for that I will directly here is the option, so display the estimated execution plan. Okay, so I will select this one. Okay, and then I will also the second option actual execution plan, and this one the statistic. So I will enable these three, and then I will execute the query. So this way we can check the execution plan. So if we check, the result will come. So this is the record, it will be selected from the database. So as of now we have the disable the index. Okay, so we have the disable the index. So whenever we find the performance from the any kind of the table, so that time we can enable this one. So this one is a the include execution plan, then include the live statistic. Okay, query statistic. So it will be show you the which query, the which physical, the basically you can check physical operator like cluster index 6, then it is also cluster index 6, and this is the object. Okay, so this is the query that we will retrieve the total number of cost. Okay, so this way we can find the some insight from that query. Also second option is a live statistic. So basically the live statistic you can check the estimated query, the process is 100%, then this is the query and retrieve the batch is 100%. So you can check. So the cluster index, you can check the cluster index 6 cluster the employee, then pk underscore employee. So this is the query, so it will be giving me so some live statistics, then execution plan. So in execution plan, you can check the cost for the execution for this. So out of 100%, so 0.00 second out of 1 second. So it will be time for the taken for the retrieving the data from the database. So this way, now as of now, this is a small data set. But if suppose we working on the large data set, then it will be take. We will also take this example in a next session. Okay. So as of now, this is the thing that we can find the performance. Okay. So second thing, that for the how we can optimize the query, and that things that I will explain in the next session. Okay. So the next one. So now as of now we have checked how we can check the execution plan. Okay, so table scan or index scan. Then the create a cluster index. So we have already created the cluster index, and then we will find the insight from the query. So the comparison, so before and after. So basically, so logical read, so basically is a high whenever without the index, and when we add the index, that time it will be low. Then execution time is a slower, and before the indexes, and after the index it will be faster. So the before the index execution plan go to the for the table scan, and then whenever we add the index, that will be go to the index 6. Okay, so this is the example, so that we check compare the before and after the index. So now what will we do? So we will go to the some real time scenario. Okay, so basically we will perform this query, and we will find the some insight from the query. Okay, so for that I will come to this, and I will run the this query. Now we can take a check. Okay, so now I have refreshed the database, and then we can check. So it will be now as of now there is a no index in this table. Okay, so I will show you. So if you go to the learn SQL, then table, then we have the EMP table, and now you can check there is a no index. So as of now there is a no index in this table. So that time you can check previously the cursor go for the index scan, but now that it will be go for the table scan. And now you can check the this is the data which will be retrieved. Okay, so the time taken 001 second. So the message you can check execution time, and the live statistic if you check. So table scan EMP 9 out of 17, so 52% the table scan will be is there. So it will be, you can check the detail of this. So you can check physical operation table scan, logical operation, it will also go for the table scan. The actual number of row for the all execution, so it will be retrieve the 9 out of 17. Okay, so estimated cost, so you can check the estimation cost, it will be the IO cost. Then you can check the different like CPU utilization cost. So the now because of the we have the not added any kind of the indexes, so it will be taken some time for the optimize the data from the database. Okay, so the cost is 100% 00, like the last session we checked that how we can add the index in that basically cluster index, not cluster index. So in this session, so we will directly go to the different step that we can perform for the SQL Server database optimization or query optimization. Okay, so whatever the thing that we can do for the optimization query, and after that we will also check the one real time scenario that it will be we will perform the and we can check how we can optimize the query, how we can that fine tuning for the database. Okay, so the in this session, so basically the performance optimization in a SQL Server. Okay, so for that, so what is the performance optimization? So basically the performance optimization is a critical and ensuring that fast and efficient query execution. Then basically it will the real-time system where the delay can be directly affected business operation. So below are the key optimization steps and the technique for the each concept explained in a real-time example to make them in a practically. Okay, so we will check all the things that can we will perform whenever we are getting the performance related issue. Okay, so basically in that first thing is that proper indexing. So whenever we are getting the performance issue, that time we will add the proper index. So for that, so indexes can be speed up the data retrieval. They can act like the book index, help for the SQL server local data faster without the scanning entire table. So whenever we add the index in any particular table, so in that time it will be not the check the all the data. It will be scan the data without loading the all the data in a one time. Okay, so this is the benefit for the index. So technique, so basically there are different type of indexes available. Cluster index, it will be basically primary key column, like for example date id. This is the id column that we will add the cluster index automatically. Okay, so whenever we create a table, that time database engine will created the cluster index automatically if we add the primary key in a particular table. Then second one is the non-cluster index. So basically it will be the based on the search like other column like date or anything. So that time we will also create the non-cluster index. And then cover index. So it will be include all the column used by the in a query. So basically for that, what we will do, so we will create a one table with a billions of records. Okay. So this is the syntax, and we will check the query. For example, if suppose we select the query like select order ID, customer ID from the order where the date order date equal to 2023, then 1201. So whenever we add the non-customer index, so this is the non-customer index. So basically create non-customer index, and this is the index name and the order. This is a table and this is the column. So basically we will add the non-customer index for the order date. Okay, so this is the first thing. The second one is the query optimization. So also we can if suppose our query getting time, so we can check like whenever we write efficient query that avoid the full table scan, unnecessary join or subquery. So in that basically the technique basically the avoid the select star. So instead of the star we can select only particular required column, whatever the required column. Okay, then use the join instead of the subquery. Okay, where the possible. So instead of the instead of the subquery we will use the join. Then filter early using the where clause. So data will be filtered. So for that we can use the where condition, and we can check the particular the where condition it will be right properly or not. Then third, the fourth one is the avoid the function on the index column. So for example, if we created the any kind of the function that will be not include the index column. So the example, for example, you can check select star from employee where the year, then hire date equal to 2023. So it is a bad the technique that we can write. So instead of this, how we can write the query, like select then first name last name from the employee. Instead of the star, we will use the from first name last name then employee, then where the hiring date greater than equal to 2023 first of first, then and hire date less than 2024 first of first. So this is a good practice for the write the SQL query. Then the third one is the execution plan analysis. So that I will show you practically. So the basically we will generate the execution plan that will be show the execute the query, identify the operation like table scan, missing index or anything. So technique for that we can use the actual execution plan in the SSMS that I show you previously. For that we can also use the shortcut like Control plus M before the running the query, and in that we can check the query will be performing based on the table scan, any key lookup or missing any indexes warning. So this way we can check the technique that for the execution plan. So real time example. So we can check the in the example like full table scan on the sales table or suggestion any kind of the missing index on the sales date. So we can add the suggestion, improve the speed. Then fourth one is the statistic maintenance. So in a SQL server there is a statistic. So if we check in a previously we can also check that there are different type of statistics that will be affected. So this is the first step. Then fifth step, participate in the large table. Okay, so for that we will participate the table into the different segment, and we can reduce the efficient for the searching the table. Sixth one, temporary table optimization. If suppose in our query we will use the temporary table. So temporary table is for the temporary storage for the table variable table any performance. So the technique best technique is that place the temporary table on the fast disk, then use the multiple data file one per the CPU core, monitor the temp table uses. Okay, then seventh step, avoid the cursor, use the set of the base operation. Okay, base operation. So the cursor it will be reducing the performance, so we can avoid the cursor. Instead of the cursor we have the different the instead of the cursor we can use a loop. So for example cursor up to this is the basically the for the update statement. So we can instead of the cursor we can use the update statement like update order set status equal to shift where the shift date is not null. Okay, then use the proper data type. So this is again important thing that you can use for the proper data type. So you can the nine, avoid the implicit conversion. So basically for example, so select star from order where the order id equal to a string, it will be in a one quote, so it will be implicit conversion. So implicit conversion means it is the converted to the varchar data type. Okay, one 1001 is a numeric field. So instead of that you can select star from order where the order id equal to 1001, so it will be not conversion, it will be happen. So 10, concurrency and locking. So basically it is a very good practice that if suppose we will use a no lock and a row lock. So basically this is avoiding the any kind of the transaction issue. Okay, so also we can use the SQL profiler, then extend the event dynamic management view. So this is the again the different the way that we can use for the optimization of the query. So now the we will go to the practically session. So in that basically first of all we will create a table, employee table, department table and the sales table. Okay, so we will add the billions of the record. So it will be helpful for the creating the real time scenario. Okay, optimize them by the indexing, creating the stock procedure. Then we can create function for the business logic, and then we will check the query optimization and tuning tips. Okay, so for that we will create the table. So I have already created this table using this script. Okay, so we have created this three table. So the department table, employee table and sales table. If I and I will share you the script with you for the creating this table and inserting the data in this table. So now I will directly show you the data from this table. Okay, so first is a select star from. So first table is a department table. Then second is a employee table. This is a department table. Select star from employee. So this is the second table. So we can check there are multiple data in this employee table. So it will be taking time because of we have the 1 million of record in this table. Okay. So we can stop and we will use top 1000 records. Okay. Now it will be executed fine. Okay. Then the next table is a sales table. Okay. So third table is a sales table. So select star from sales. So if we directly execute the sales, so it will be taking time because of there is a 1 million data in this table. Okay. Because of we have created the script, and using that script we have the added the data. So I will stop this, and instead of this I will top 100 1000. Okay, and I will show you the data for the sales data. So basically the sales data based on the employee who are the sales the data. Okay, and this is the department. Okay, so if I show you the statistics, so how we can check the statistics? So if I select top 2000 data. Okay, and I will enable the execution plan, and I will execute the query. So data will be retrieved. So it will be take 0.01 second for the 20,000 data. Okay, and if I show you the execution plan, so you can check the cost for the this, and you can check we have the added the primary key constraint on this table. Okay, so the cluster index will be there, but it will be taking time because of the we have the lot of data in this table. Okay, so now the next step, so we have the created the table, we have the added the data. Then the next step, indexing optimization. So basically we have the not created the indexes. So what we will do, so we will create a indexes. Okay, so for that I will directly copy the this query, and I will create a new query. In that new query I will, so first thing is that we will create a non-cluster index on the employee table with the department ID. So if you check, so this is my employee table. In the employee table we have the employee ID, employee name, department ID, and the hiring date, salary. So we will first of all we will create a non-cluster index on this table. Okay, so we will create later, but before that what I will do, so I will directly create a one procedure. Okay, so this is my procedure. So this procedure basically create procedure. This is the USP get monthly sales summary. So and this we will pass the two parameter. So from date to date, then begin, and this is a simple select statement. Okay, so this is the simple select statement. In that we will select the data like from the sales table we will join the employee, then department, and where sales date between the from date to date, whatever the date we will pass, that will be retrieve the data from the this table. Okay, now the command completed successfully. We have the created the store procedure. Okay, and now what we'll do, so we will create also one function. Okay, so if suppose we execute the this function, so how we can execute the so this one. So basically this is my the procedure, and we will pass this parameter. So this is the from date and this is the to date. If I execute this query, then it will be take some time because of the we have the not added the non-cluster index. So we will, if you check the from date and to date, it will be based on the sales date, s dot sell date. So s dot sell date. So this is a non-cluster index that still yet we have not added. So till we are getting the some performance issue because of data, it is not retrieved from the table. The reason is that because of the data, I will create a function. Okay, in the next, so we will create a scalar function based on the salary bonus on the salary. So for that I will copy the created the function. I will copy, I will go to the new query, and I will create a one function. Okay, so function basically dbo dot fn underscore get bonus. So salary is the parameter, and it will be retrieve the decimal. It will return the decimal, the means the data. So it is a begin, then bonus, then when the salary execute this one, so it will be create a one function. Okay, so we have the created the function. So now, so for the query optimization sample, so so we will take only 10-day data. Okay, so we will stop this and I will execute this one. So only primary key constant and primary key index is there. Okay, this is a cluster index, but this cluster index we will add on the primary key. If you check, so whenever we create the table, that time there is a sales ID. You can check key. Okay, so now my procedure execute, and it will give me the four records. For the four records, it will be take around 45 seconds. Okay, so you can check for the only four record, it will be take the 45 seconds. So if I execute this one with the execution plan, so what it will be give me the statistic. Okay, so what I will do, so I will execute with statistic. So because of it is a time taken process, so I will add the execution plan and we will check what it will be suggested. Okay, so for that I will execute again. Okay, so you can check, it will give me the this estimation cost. Okay, so the result will be, we will get the result, and we will also get the four record affected. But the execution plan suggested that missing index. Okay, so create a non-cluster index, and there is a missing index name and on the dbo cells. Okay, so for that I will, you can right click on it and you can check missing index detail. So if I click on it, so it will be suggested that we can create a non-cluster index on the this is the name of the non-cluster index, and on sales date include the emp id and sales amount. So if we add this one, so then it will be might be take the less time. Okay, so as per the suggestion, so we have the already checked that we need to add this index. Okay, so what I will do, I will directly create an index. So I will, in between that, non-cluster index on the sales sales date. Okay, and now I will execute this statement. Okay, okay, now I have created the non-cluster index. So if you check, can you can check in a non-SQL, then table, and then you can check the cells. So the indexes, as of now there is a two indexes. This is a indexes. This is a non-cluster index that we have created. Okay. So now then what I will do? I will check the execution now again. So as of now it will be take how many time? So data retrieval time is the 1 second. Okay. So and if I execute this one, then now the error will be gone and it will be take the less amount because of we have added the cluster index, non-cluster index. So due to that, it will be data will be retrieved fastly. Okay. So this is the execution plan. So if you check the execution plan, so whatever the different table that we have created, so it will be show the actual execution plan in a backend. So this is the one thing, and second thing, we can also add the SQL profiler. Okay, so you can connect and event selection. Here we have the all event filter. So here we can select the database. So we have the database like learn SQL. So I will add the this database. Okay, whatever the database. Then click on OK and click on run. So now it will be start for the tracing the data. Okay. So if I as soon as I will execute the this execution, then it will be start for the capturing the data. So you can check it will be capture the data. Okay. So how we can find? So you can check say the statistic, then this one and this. So this execution run in a backend, so it will be showing that the data like select star form like this one, then this one. So this is the step by step for the find out the data in a backend. Okay. Okay, so if I run the data for the 30 per day, so now if I execute the this data, then also it will be give me the in a very less time. Okay. Okay, so this is the thing that we have now completed. So we can also check the SQL profiler for the optimization whatever the backend is that. So it will be we will check in a backend also. So basically now we have the completed this one. So I will also show you that how we can check the execution plan using the SQL profiler. So this is the thing that we have completed in this session. So if you have any question that you can ask. Okay.